Okay, so for our topic today, we will be talking about expanding the bracket and its identity, all right, and its identity over here. Okay, so let's take a look at this question over here, all right. Now, lots of students, they like to do this. They will see over here, oh, that's x, that's 3 over here, and everything I have to square it. So lots of students will write down this answer, x squared plus 9. All right, looks correct, right? But what if I tell you that this is actually wrong? All right, this is actually wrong, and it's a very this is actually wrong, huh? And it's a very common mistake. Okay, it's a very common mistake that a lot of students will make. Okay, all right. So when we are dealing with this kind of question, how do we expand this correctly? Okay, now to do this properly, let's try to go back to basic. All right, let's try to go back to basic and let's understand what does this mean. I have basically something squared, right? So if I were to write like I have 3 squared, you will understand this as 3 times 3. It is just multiplying by itself, correct or not? So I can apply this understanding for this same thing, right? So let's see what's going to happen. So I'm saying that x plus 3 squared, I can rewrite this as x plus 3, x plus 3. All right? After all, I am multiplying by itself, right? But over here, what should I do next? All right. Now, in our previous classes, you might be very familiar with solving questions that looks like this. Okay? So all you need to do is to distribute, all right? Or we just say expand. All right? Just expand accordingly, which will give you 2x plus 6, right? So what we are going to do here, it's going to be similar to this. We are going to use this idea over here to expand, all right? So let me show you how we do that. If you notice this, the second part of the question, they look the same. The only difference is the first part, right? There are 2 terms over here, but instead there are 1 term over here, right? So what I'm going to do is just distribute the 2 terms accordingly. All right, so that's what I want to do here. Huh? So see how I done. So I have, my first term here. All right, I'm going to expand it accordingly. So all I need to do is to take this and multiply with this guy first. All right, that will give me x squared, right? And what I will do next is I will take the first term again and multiply this guy over here, and that should give me 3x plus 3x, okay? Right, looks similar to the example earlier, but I'm not done yet because there's another term over here which I have to multiply, right? So let me do that. So I will multiply with this one, okay? So that will give me another 3x, all right? And finally, there's one more over here. I will just multiply here. And that will give me 9. All right? So what's going to happen next over here? We are just going to expand this. All right? We're just going to expand this now. Sorry, I mean like just simplify this. Collect like terms. So I should get x squared plus 6x plus 9. Can you see that? This one is the correct expansion over here. All right, not this one. This is the correct expansion over here. All right, but let's go deeper into this. Because if you compare this answer and this answer, you might notice there will be some similarities, right? So the similarities here is both of them have x squared and both of them have 9. But what is odd about this, it's this guy over here, 6x, all right? So you might be wondering, what is this 6x? Where does this 6x come from? in the first place? All right, where does it come from in the first place? I'm going to show you where this come from. All right, I'm going to prove to you where this 6x come from. All right. So to show to you this proof, I'm going to change this into a diagram so you can see a big picture of what's going on. All right. So I'm going to prove to you this by using a square. Why a square? Is because we are squaring. That's the reason. Okay. So if I were to give you an example, like 3 to the power of 2, 3 squared. So what are we finding actually? What we are finding is the area of a square, right? Okay, like for example, a square here, 3 square is going to basically mean I have my 3 as my base, 3 as my height, okay, and the area of the square, is true enough, it's going to be 9, right? So I'm going to use this understanding over here to prove where does this 6x come from, okay? So I'm just going to erase this first, huh? So first, let me draw out my square. Okay, all right. So first, let's fill out our length. Okay, as we know that this is a square, so all the lengths are the same. And each length over here, based on this expression, that's gonna be x plus 3. And this side is gonna be x plus 3. All right, let's start with that first, okay? But what I'm gonna do is I'm gonna split this x plus 3 into their respective length, so you can see a bigger picture of what's going on. Now let's just say, for example's sake, I will put a mark over here, and let's just say from here to here, okay, that's the length of x, all right? And let's just say from here to here, that's the length of 3. So if we add up, does the expression of this length, does it add up to x plus 3, right? Okay, so since we are dealing with a square, so all my sides are supposed to be this, right? So I'm going to write down over here. So let's just say I put a marking over here, and I say that from here to here, that's my x, right? From here to here, that's my 3. Okay? Follow so far? So x plus 3 square times x plus 3 square. Okay? So what I'm showing you is this guy over here, right? So what I'm going to do next is I'm going to draw some line over here, particular to this. Okay? So I'm just going to draw some dotted lines. You'll see what's going on in a while. Oops. Okay. Now I'm done. So before we continue, let's fill up some more like empty points over here so you can see what's going on. Huh? So what do I have here, right? If you can work together with me, this length from here all the way to here, that should be x, right? From here to here, that should be 3, right? Here to here, that should be x again. From here to here, that should be 3, okay? All right. So what's next over here? Okay, I'm going to show you where is all these guys in this picture over here. Now, can we find the expression? Because since we are talking about area, can we find the expression for this big square? This big square, what's the expression? Okay, I have x plus x, so the expression inside this square should be x squared, right? That's this guy over here, right? Okay. Now, can you see where it's 9 in this diagram? 9 should be this small square over here. 3 times 3, the area over here, that's 9. All right. Can you see what's missing over here? I have 2 more rectangles, right? I have 2 more rectangles, right? And what's the expression for this rectangle? For this rectangle, that's going to be 3x. And for this rectangle over here, that's going to be 3x. Okay, and we can see that both of these are like terms, so which means we can add them up together, right? So 3x plus 3x, do I get back this 6x? And that is where That's where that 6x come from. Alright, so this is the proof over here lah. Okay? Now I'm going to show you, alright? I'm going to show you something extra over here, alright? Now you can work this out, alright? You can pause the video, alright, and work this out. I want to give you some few expression over here. You can work this out yourself. So x plus 2 square, alright? X plus 3 square, x plus 4 square, x plus 5 square. Alright, so what I would like you to do, you can just quickly pause the video to work this out very quickly. Okay, well, in the meantime, I will just write out the expression lah. So why am I asking you to do this? Because I want you to try to identify a certain pattern over here. Alright, so of course, if you have done expanding, you should get the following answer. Alright, you should get x squared plus 4x plus 2, x squared plus 6x plus 9, x squared plus 8x plus 16, and finally you should get x squared plus 10x plus 25. Okay? If you have expanded everything correctly, you should get the same expression as me. Okay? But what is the interesting thing that I want you to take a notice here? It's these numbers with the middle term and the final term only. Do you see what are the patterns you see over here? Right? Try to look at the numbers and the middle term and the last term. Let's take a look at that. Do you notice that all the middle terms here, it's all 2 times of this number? Right, you see? 2 times 2, 4. 3 times 2, 6. 4 times 2, 8. 5 times 2, 10. Can you see that? Alright. And what do you notice about the last number here? Alright, if you notice about the last number here, it's gonna be everything squared, right? Like 2 squared, that will give me, oh, I'm sorry over here, my mistake. This guy should be 4. 2 squared should be 4. 3 square, 9, 4 square, 16, alright, and 5 square, I should get 25. Can you see that? So based on that, we can come out with a general expression over here. Alright, we can come out with a general expression over here. Alright, or we can call it as an identity over here. So if I have x plus a and I raise it to the power of 2, right? That will always give me x squared, alright? That will always give me x squared plus 2 times of a. But do not forget your x over there, alright? Plus a squared. Alright. This over here, it's going to be the general expression for all these things. And we have a special name for this. Right? We have a special name for this. All these things that you see over here, all this expression, we call it, oops. Alright. We call it a perfect square. Alright. This identity here, it's what we call it a perfect square. Right? After all, we are dealing with a square and they are perfect. All the sides are the same. Hence the name perfect square. Okay? So let's take a look at these, digest and understand the proof over here first. Okay?